language model. So example, you can see here, example, we have already discussed. Say this is our collection, and in this collection we have to count the total number of terms. That will be r n, and the numerator, which will be the term occurrences in the collection. Term occurrences in the collection and total number of terms in the collection. So for university, as you can see here in the box given here, there are two university. So 1, 2, the count is 2, occurrences is 2, and we have total number of terms 20. So 1 second. So calculation has been done, 2 divided by 20. We are finding all the probabilities using unigram model, unigram language model. And if the query is like University of North Carolina, then you have to multiply the corresponding probabilities of the terms in the query. So for University of North Carolina, then this probability of university into probability of into probability of North into probability of Carolina. So likewise, you can find the unigram language model. Then moving on, see example, University of North Carolina. This has been calculated and we got a value here. So for Chapel Hill also, these two corresponding probabilities you need to multiply and you will get the result. Now, see for this is for some larger database, for larger collection of terms. So for larger collection of terms also here, instead of counting the whole thing from the collection, they have given the term frequency along with the number of terms in the collection. So it is very easy to find the unigram language model from the table given here. So this P of term, that means probability of the respective terms given here, can be directly calculated using TF and N from the table. Now, this also we have discussed in our last class. For bigram model here, it will be, we are going to find the probability condition on the previous event, condition on the previous term. For this particular example, here you like green cream. So for this also, so probability of you will be written here. Then probability of like condition to the preceding term. This is the preceding term is u. So condition on the preceding term, u, probability of u. Then probability of green, condition on probability of like. Probability of cream, condition on probability of green. So likewise we can find for bigram language model. And for chain rule, full chain rule, here the probability of u, then probability of like, condition on u, then probability of green, condition on u like. That means it is a continuous chain. You will have a continuous chain. For the first particular term you see here, u, it is condition for the probability of like, it is condition on u. Now, when I find for green, I need condition on u like. For bigram, it should be green condition on like, but for full chain, it must be continuous one. So it should be connected. So probability of green condition on u like. Probability of cream condition on u like green, like this. Okay. So This is regarding the uh, bigram, unigram, and full chain rule language models. So these are some models, but for our calculation purpose, we will be using normally unigram. Sometimes we may use bigram model based on the uh, condition and the question given. Okay, but normally we will be using unigram language model. We have diagram, 4 gram, trigram, 4 gram, n-gram, and so on. So example already discussed, but here this has been explained again for n-gram. Uh, See, in this collection we have red balls, blue balls, yellow, and three ball, four, 1, 2, 3, 4, 5, 6, 7, 8, 9. Our collection is 9. We have 9 balls. So if we consider each ball as a term, then we have 9 terms. N will be 9. We have n equal to 9. So our query says to find probability for red balls, yellow, red, and blue ball. So now the same how we find the probability distribution for the respective balls in the earlier example, you can do that one. So we are finding the probability of for red 1, 2, 3, 4, 4 divided by 9. Probability for yellow, it is 1, 2, 2 divided by 9. Again, probability for red, it is 4 divided by 9. And probability of blue, it is 3 divided by 9. So when this query is there, finding the probability for red, yellow, red, and blue, then we have to find this way, multiply all these things, all the probability distribution values. So n-gram is nothing but condition on preceding words. As I explained you here, for bigram, the condition on the preceding term. So for like, finding probability for like, condition on preceding term for like is u. So condition on u. For green, condition on like. For crim, condition on green. Likewise, in n-gram language model, the same thing we are going to follow, that we are going to find the probability distribution for a particular term condition on the preceding terms. Now, document language model. Document language model is also similar, but little bit different. Here we will be considering the full document. While we calculate for unigram language model, we consider just a few collection, but in the document language model we will be considering larger documents. We will be considering larger documents. So the steps are same. We have to split the document text into terms, then count the number of times each time occurs. So term frequency we will be finding, term frequency, and total number of term occurrences. Total number of term occurrences in the collection, which is n. Then we will find the probability by finding using this formula. And probability here. So we will see the direct generic example. See here. So when document language modeling, we are considering a document like this. Okay, we are considering a document like this. So this is for a movie Rocky 1976, and a plot has been given here. Okay, so like this, as a whole document we will be considering in document language modeling. According to this plot, I have just listed out some most frequent occurring terms along with their term frequency and along with the collection number of terms in the collection. So term frequency, that means how many number of times this particular term is occurred in the collection. And this is 420 ND is nothing but what? total number of term occurrences. Okay, total number of term occurrences. So it is given here according to this plot for 20, and A is occurred 22 times. Rocky occurred 19 times, 2 occurred 18 times respectively. Okay, so respectively it is given here, and I have calculated the particular corresponding probabilities also. So probabilities also is calculated here. So when it is asked you to find the probability for a given query, for example, uh, a boxer is a pet. A boxer is a pet. Then same way like how we do in unigram language modeling, we have to find probability for A, we have to find probability for boxer, we have to find probability for is, we have to find again for A, then pet, and finally you multiply all the probability values. That will give you the probability for this particular text. Now, query likelihood retrieval model. Query likelihood retrieval model. So here in query likelihood retrieval model, we will be finding the score. The concept is same, okay, right from the last few classes which I have been conducting regarding the probability distribution. The concept is same, but how we calculate, how we take the value, that is little different, okay. So from chain rule, probability distribution, conditional probability, prior probability, all those concepts right from the beginning until now, the concept is same, okay, similar. Now let us see query likelihood retrieval model. Here also we are going to take the concept of probability distribution. So the whole chapter is based on probability distribution. Okay. Now, so I have 6 documents here. So each document contains some set of information. Some terms are contained here. So instead of writing the terms for your better understanding, I'm just giving you a diagrammatic explanation using the balls. Okay. So now D1 contains red balls, blue balls, and orange balls. Similarly, all the D5, D6 documents are there in our collection. It contains respective red, blue, orange balls with different numbers. Okay. Now, what we have to do is we have to find probability for each document's for the respective colors. Red, we are finding the probability. So for red, 1, 2, 3, 4, 5. 5 into 4, 20. Okay, so there are 20 balls in D1. So in our document, 1 contains 20 terms. So for red, how many red balls are there? 5, 6, 7, 8, 9, and 10. Okay, so 10 divided by 20, 1 by 2, which is equal to 0.5. So that is what it is given here, 0.5. Okay. So for blue also, you just consider only this document D1 because we are going to calculate only for document, each document. So here in query likelihood retrieval model, what does it say? Score each document denoted by D according to the probability given by each language model to the query denoted by Q. So we will be having a query and we are going to find the score for each document. So we have 6 documents. For each document, we have to find the probability distribution. Now, you can see here how the probability distribution calculation, it is already done. So 1, 2, 3, 4, again 5. So 5 divided by 21 by 4, 1 by 4 is equal to 0.25. Similarly, for orange is also calculated for D1. Then for D2, we find probability for red, blue, and orange. Okay. For D3, D5, D6. So these are just some document IDs given. Uh, So now let us find the score. So before we find the score, we are taking a query, Rocky versus Apollo Crete. So this Rocky versus Apollo Crete query is taken from this plot, from this document, Rocky. Okay, from this plot, we are taking the query. So now our query is Rocky versus Apollo Crete. So here, for respective query, we have to find, say for example, Rocky. So Rocky, we have to find from D1, then from D2, then from D3, then from D4, and so on. Okay. So for each document, we have to find separately. So our plot may contain, our document may contain more than 5 documents or 6 documents. So in document language modeling, we will be having a larger collection, larger data. So we may have more than 1 document, 2 documents, 3 documents, 4 documents, and DN documents. So let us see the example how it's been calculated. So for finding Rocky versus Apollo Crete in D5. So we are going to find from D5. So score is calculated for each document, right? So when it is asked, the query will be like this: Rocky versus Apollo Crete from D5. So you have to find the score for D5. When it is said D4, then you have to find the score for D4. If it is set for D3, you have to find its probability distribution for these terms from D3. So now in this query, it is asked to find from D5. So we will be using our D5 document 5, and probability for Rocky from D5 we will be counting, probability for versus from D5, probability of Apollo from D5, probability of Crete from D5, and finally you will multiply and you'll get the score for the query. Okay. Now smoothing. Smoothing is one important topic in this, because so when you consider a larger collection, okay, so probability distribution we are going to follow. But in case, suppose, so you can see here in this collection we have only red, orange and blue balls. Red, orange and only blue balls. Suppose if there are chances to take out a yellow or green balls from the back. When you have a bigger back, when you have a larger collection of data, you may have chances to pick up a yellow ball or a green ball. So in that case, we need to use smoothing. So suppose if your bag, if your collection is a sample from different bigger bag. So if our collection is taken out from another bigger collection, okay. So for this example, we are just taking as bag. If this bag is a sample from a bigger bag, different bigger bag, then we may have chances to pick yellow and green balls also, because the bigger bag may contain different other colors, right? So the bigger bag may contain different other colors. So we may have chances to pick up yellow and green balls. Okay. So in that case, we use the technique of smoothing. So for, in this particular example, see here, for red, we can find directly the probability, because red balls are there. Total number of balls are already, we can count from here. And by counting the total number of balls and total number of red balls, we calculate probability for red. So we can calculate probability for blue also. Similarly, we can calculate probability for orange. But in case if we are to pick up a yellow ball from the bigger bag, then our probability will be 0, because here in this collection we don't see any yellow balls, right? So our probability will be 0. But in our condition, we should have a chance to pick up yellow and green balls. So our probability should not be 0 for green. Our probability for green should not be 0. That's why we will add 1. So that is at 1 smoothing. At 1 smoothing. So you can see here we could add one ball of each color to the back, which gives a small probability to unobserved outcomes yellow and green. So in order to get a smaller probability, we will be adding one ball of each color. One ball of each color. So actually, in this we have how many red balls? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. But now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So one ball is added in the back for all the
Excuse me,
colors.
ma'am. Someone is waiting to join, ma'am.
Okay. So one ball is added in the back for all the colors, not only for yellow and green, but we should add one ball of each color to the back. So actually our red ball was 10 in this earlier example. Now we have added 1. So our red ball becomes 11th now. Similarly, blue balls. Blue balls was 5 in the earlier collection. Now we have added 1, so it becomes 6. For orange also, it was only 5 balls here in the earlier collection. Now after 1 has been added, it becomes 6. Then yellow color we have added 1, green color we have added 1. So our probability for yellow becomes a non-zero value. Our probability for green becomes a non-zero value, right? So this technique is known as at one smoothing. At one smoothing, we are adding one ball for each color in the back. Okay, so we have added one ball for each color in the back. So that we won't be getting a zero probability value. So after adding, as a result, it also reduces the probability of observed outcomes. So now probability for red, blue and orange will be reduced by a small amount because since we have added 1, 10 divided by 20, it is 0.5, whereas 11 by 25 will get little lesser value. So this technique is also known as discounting. This technique is also known as discounting. Okay. So at one smoothing, also known as discounting. So uh, this concept we will be using in our normal calculation for terms also. So when this is we are using red color, blue color balls, but in our example we will be calculating using the text. Okay. For your understanding purpose, I have just used the color balls, but in our exam, we will be using the text. And that example also we will discuss using the text. So you can see the difference here. This was initially before the normal R collection, and this has been added one color for one ball for each colors and at one smoothing. This is without add 1. This second one is with add 1 smoothing. So in without add 1, the probability of yellow and green are 0, whereas after add 1, the probability becomes a non-zero value. Then another effective approach for smoothing is linear interpolation. So we use at one smoothing here is one technique for smoothing. Okay, for smoothing The first technique we discussed is adding one color, adding one ball for each color. And now it is linear interpolation. It is another approach for smoothing, linear interpolation. So same concept, but here we use two language model, one for the document which is associated with the document, the other one which is associated with the entire collection. So you can see here, let theta d denote the language model associated with document D, and theta c denote the language model associated with the entire collection. So using the linear interpolation formula, the probability is given by this formula given down here, probability for the term in the document. So alpha, we use a constant value here, a parameter, tuning parameter. Then probability for the term in the document, and this is probability for the term in the entire collection, the second part. So now linear interpolation smoothing, you can see the probability given to the term by the document language model, and this part is probability given to the term by the collection language model. So that means this probability is associated with the entire collection, and the first probability is associated with the document collection. That means with the document language model. Now we'll see one calculation. See, we are going to find the score. We are going to find the score using this probability formula. So score has been calculated. This is product for with for the document, probability for the document, and probability for the entire collection. Okay. So let us see the example which we use this formula. So this example, this one is without smoothing technique. Our query is Apple iPad. Our query is Apple iPad, and we have two documents, each with 50 terms. So D1, for D1 n equal to 50, for D2 n equal to 50. And our query is Apple iPad. So we have two documents here. Each document contains 50 terms. So you find the probability for Apple. Let us find uh, if Apple occurs two times in the document. So we are considering that Apple occurs two times in the document D1. So 2 divided by 50, it is 0.04. Similarly, in document D2, if we consider Apple occurs 3 times, then 3 divided by 50. Okay, so we are considering Apple occurs 2 times in document D1. So Apple occurs 2 times in document D1 and Apple occurs 3 times in document D2. So corresponding probabilities are calculated. 2 divided by 50 is 0.04 and 3 divided by 50 is 0.06. Now, similar way for iPad occurs 3 times in document D1 and it occurs 2 times in document D2. Then corresponding probabilities are calculated. So we got 0.04 and 0.06. If you multiply these two probabilities, we got the score for D1, it is 0.0024. Score for D2, 0.0024. So same probability value. So same probability values we got. So 0.0024 for D1, 0.0024 for D2. So here with no smoothing technique, our score becomes same. With no smoothing technique, our retrieval method retrieves same score value. But now with smoothing, we can make it different. Since it is the scores are same, so we may get confused that this may be for the score is for document D1 or the score is for document D2. Now let us consider a larger collection. Consider a larger collection. See here, apple occurs. This is for the document, okay? This is for the document. Apple occurs 2 times in document D1. Apple occurs 3 times in document D3. iPad occurs 3 times in D1. iPad occurs 2 times in D2. But but if apple occurs 200 times in the entire collection, okay, so this point you remember, if apple occurs 200 times in the entire collection, that is our entire collection has 1 lakh terms, so 10 to the power 6. Our entire collection has 10 to the power 6 term occurrences, whereas apple in that entire collection it occurs 200 times. So when you find the probability, you see here probability for apple in the entire collection. So it will be 200 divided by 10 to the power 6, which is equal to 0.0002. Now, similarly, suppose if iPad occurs 100 times in the entire collection. In the entire collection, it occurs 100 times. So, we have to find probability for iPad in the entire collection. 100 divided by 10 to the power 6, which is equal to 0.0001. So, this point has been added because in order to make the score different value. Now you can see here, this is the formula for finding the score, and see probability of apple in the document, probability of apple in the entire collection. The probability of apple in the document is 0.04, taking the value from here. Probability of apple for the document, this one. We are taking it from here, okay? 0.04, 0.06. So probability of apple in the document D1, in the document D2, 0.04, 0.06. Now, probability of apple in the entire collection. Probability of apple in the entire collection is what? 0.002. 0.0002. So, probability of apple in the entire collection is 0.002. Probability of apple in the entire collection is 0.0002. So, we have written it here. Now, score. Score is what? You have to use this formula. We have to use this formula. How do we get 0.0201? We have to use this formula. So product is here, product of what? Alpha is 0.50, a constant value. This is a changing parameter. So probability for the query in the document. So for the query in the document is 0.04. So you have to multiply 0.50 alpha value into probability value 0.04 plus 1 minus alpha, which is 0.50, into probability for the query in the entire collection. That means probability of apple in the entire collection, that is 0.002. So when you calculate this value using this probability of apple in the document and probability of apple in the entire collection, we will get 0.0201. Similarly, we have calculated for document D2 also. And after that, iPad also we have calculated. For iPad, this is taken out from this value for iPad in the document D1 0.06, in the document D2 0.04. That has been written here. And after that, iPad in the entire collection. iPad in the entire collection, what is the value? 0.0001. So I have written it here. After that, using this score formula, we have calculated and I got 0.03005. Okay. So the first part is for the document, the second part is for the entire collection. And after calculation, using this score formula, I got 0.03005 for D1 and for D2 0.02005. Now total score. So I got score for Apple, I got score for iPad. Then you multiply these two score value, score for Apple into score for iPad, and you will get total score. So which is 0. So this value 0.000604,005. Whereas for document D2, score for Apple is this value here 0.0301 into score for iPad, which is 0.02005. So we got a little different value, slightly different value here, 0.000603505. So this gives a more detailed value rather than considering without smoothing. Okay, so this was without smoothing. We got this score value same, whereas with linear interpolation smoothing, we got the score slightly different. So this is how we find linear interpolation smoothing and at one smoothing. So smoothing techniques, we have two here. We have discussed two techniques. First technique is at one smoothing. Second technique is linear interpolation smoothing. Okay. Next.
Ma'am, excuse me, ma'am.
Yes, yes.
Ma'am, regarding the second last slide, in the second last slide,
Mm,
uh, the term we decided the term frequency for this Apple and iPad
mm.
randomly, or is it decided randomly? These two
Yes,
hundred
yes,
and
it
one
is
hundred.
decided randomly because this is just an example. But the calculation should be in this way. Okay. What I am just
100.
trying to explain is calculation should be in this way. But the numbers given here are just random numbers. Okay. Random numbers. Or
Okay.
a collection, say suppose corpus is one database, right? So this
Mm,
corpus database may have 10 to the power 6 term occurrences, and this corpus database may have Apple occurrences 200 times, iPad occurrences to 100 times. So these are some random numbers taken for your explanation purpose. Okay.
okay, ma'am.
Okay. Then next one is mm, text classification. Next one is text classification. Text classification, we will just start the introduction and we will continue in our next class. Text classification. So let me just say, so language model, after language model, we have text classification. Yeah, this one, text classification. Okay. And naive Bayes, text classification and naive Bayes. Here we are going to classify some set of text based on observed data. So given a set of classes, we are going to determine which class a given object belongs to. So this is nothing but text classification, right? So we will be given some label classes and unlabeled class. So that unlabeled class we are going to determine to which label class it belongs. So classification, start with the example. So class name can be anything, can be any text. So for example, China can be one class name, coffee can be one class name. Then, okay, we'll start with the second part. Text classification problem. Text classification problem. So we have a description D or a document D that belongs to X of a document. A description D belongs to X of a document, where X is the document space, where X is the document space, and a fixed set of classes C. Fixed set of classes C. So we have C1 class, C2 class, and so on. Up to CJ classes can be there. Okay. So these classes are also called as categories or labels. These classes are also called as categories or labels, and the document space X is some type of high dimensional space, and the classes are human defined. Okay, so the classes name are human defined for the niche of their application. So as in the examples, China and the documents that talk about multi-core computer chips. So this is some explanation about what is class and what is class name. Then some set of documents that belong to a particular class. Okay, so this part has been taken out from your textbook, which I have already sent ebook, right? So from that it has been taken out. You can refer that one. But for your just explanation purpose, we will directly study the example and you will understand it clearly. So for this D and C, so D's document C is your class. So it will be in this pair. Okay, it will be in this pair. Say document and C, D and C, you see here, Ising joins the World Trade Organization. So this particular text from the document space is belong to China class. Okay, this document, Beijing joins the World Trade Organization. This document is belong to China class. So this belongs to China class. This particular document belongs to China class. So it will be written in the form of DC, document and class. D stands for document, C stands for China. Then our classification function is defined here, gamma, that maps documents to classes. So, okay, so using a learning method or learning algorithm, we wish to learn a classifier or a classification function. So we have defined here a classification function gamma, which maps the documents to classes. So X maps C. We can say document maps to C. That means here this document it maps to the particular class. The Beijing joins the World Trade Organization. This is a document that maps to class China. Okay. So we will see this type of learning is called supervised learning because a supervisor serves as a teacher directing the learning process. Because why? We are given some label classes. Using the label classes, we are going to analyze, we are going to define, we are going to study the features, and we are going to assign the unlabeled class a label class from the given set of classes. That's why it is called supervised learning. So we have name-based text classification. One type of classification is given here. So according to this classification, here also we will be finding the probability. So this whole chapter which I have been teaching from last week, it is based on probability distribution. Okay. So we introduce multinomial naive-bayes or multinomial naive-bayes model, a probabilistic learning method. Okay, so it is also a probabilistic learning method where we are going to find the probability of a document D being in class C is computed using this formula. Okay, probability of a document D in class C is computed using this formula. Okay, so calculation we will see so that we will understand where is the calculation part. This you can study. I'll just come to the calculation part. So these are all for finding the conditional probability, prior probability, posterior probability. So in example, all these terms will be used. So we will just go to the example and you will understand the formulas also. So this is this concept, same thing. To eliminate the non-zero probability, we are using add 1 or Laplace smoothing. Add 1 or Laplace smoothing, which simply add 1 to its count. Same concept like what I taught in using the color balls, right? So here we are applying that concept, we are applying here in our terms. So we use add 1 or Laplace smoothing, which simply add 1 to each count. So to every terms, we will be adding 1 frequency. So suppose if the term, for example, add or number, say if our term is P and it has uh, 4 occurrences, the frequency is 4, no smoothing. Then with smoothing, the T occurrences will be 5. So this is with at 1 smoothing. Okay. So like this, suppose you consider term T, it actually has 4 occurrences in the collection and there is no smoothing, but with smoothing we will be adding 1, so it will be 5. Okay, so like this. So this also we will use the formulas to count for the calculation purpose. Now this is the example. Okay, now this is the example. So all the probability formulas you see here, NC by N, NC is the number of documents is in class C and N is the total number of documents, then conditional probability, how to find, so you can just check it out from this example. Okay, now this is the example. Okay, I have 4 documents. I have this example is directly from your textbook. You can also refer the textbook. I have 4 documents. So what's in the documents? Chinese, Beijing, Chinese. So these are the words in the documents and the corresponding document ID is 1. And this particular document is this belongs to China class So C equal to China. Yes, yes class. Yes class is nothing but China. So yes class, document D1 belongs to China class, which is yes class. Document D2 belongs to yes class. Document D3 belongs to yes class. Document D4 belongs to no class. That means it is not a China class. Now, our testing test set is document D5. This is a new document. D5 is a new document. And we are going to check this particular document belongs to which class. So, a question mark is given here. That means we don't know. This is an unlabeled document. Unlabeled document. We don't know which class does this document belongs to. Therefore, we will be using the net-based text classification method in order to determine which class this particular D5 belongs to. So, training set we have for documents D1, D2, D3, D4. These are the words in the document, and D1, D2, D3 belongs to China class, and D4 belongs to not China class. And D5, it is a new document. This D5 new document, it is not assigned to any classes. So based on the features and by finding the probabilistic distribution for all the terms, we are going to find, or we are going to assign the China class or not China class to this particular D5 document. Okay. So we need to classify the test document as the prior probabilities and conditional probabilities. So we need to find two types of probabilities here, prior probabilities and conditional probabilities. So for finding the prior probabilities, here for China class, 3 divided by 4. How many China classes are there? 1, 2, 3 China classes are there. Okay, for 3 China classes are there, so 3. 4 is how many documents are given? 1, 2, 3, 4. So this NC by N. NC by N, this one. Okay, this is for prior estimate. Prior estimate NC by N is the number of documents in class C. That means for that particular class. And N is the total number of documents. So NC by NC is nothing but for China class, how many classes are there? 3 classes are there. So 3 divided by 4, total number of documents in the collection. We have 4 documents. So here we don't need to count the test document, okay? We have to count only the label classes. Label classes is one is not China class, the remaining 3 are China class. So label classes are 4. So 3 divided by 4 for China class. And for not China class, it is represented by C bar. C bar is nothing but not China class. For prior probability for not China class is 1 by 4 because we have only not China class 1 not China class. 1 not China class 1 divided by 4. So we have calculated prior probabilities here. Prior probabilities for China class, prior probability for not China class. So for the China class, we got 3 divided by 4. For not China class, we got 1 divided by 4. Now we will find conditional probabilities. Now we will find conditional probabilities. So I will just teach up to finding the conditional probabilities for today, and the remaining explanation will be done in next class. Okay. Then conditional probabilities for each word we have to find the conditional probabilities. For each word we have to find the conditional probabilities. So for Chinese we have to find, for Beijing we have to find, then for the unique terms, okay. Once if you find for Chinese, no need to find for this second Chinese. Once if you find for Chinese, then you have to consider all this Chinese and you have to calculate. That's why once for the unique terms only, we are going to find the conditional probabilities. So what are the unique words here? Chinese, Beijing, Shanghai, Macau, Tokyo, and Japan. So this 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. So these words we will be finding. Let us see. So 5 plus 1 in the numerator and in the denominator 8 plus 6. So this is from the denominators 8 plus 6 and 3 plus 6 because of the length of text in China class and text in North China class are 8 and 3. Length. For denominator is nothing but the length. So what is the length for China class? 1, 2, 3, 4, 5, 6, 7, and 8. So how to find the length? Document length in Occupy model we have already calculated. We have already learned how to find the document length. So document length is just the numbers which you have to count for all the documents. So in this, for China class, the length is so 1 Chinese, Beijing, Chinese, 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 Shanghai, Chinese, and Macau. For China class, we have 3 China classes. So it will be 8. 1, 2, 3, 4, 5, 6, 7, and 8. Clear? Once again, I'm telling you this denominator 8 plus 6, and for North China class 3 plus 6, right? So let us first see for China class the document length, the denominator 8 plus 6 and 3 plus 6 are because of the length of text in China class. C stands for China class and text for C bar is for North China class. They are 8 and 3 respectively. And the constant B is 6 as the vocabulary consists of 6 unique terms. So this is B. That means we are using this this formula. This is for advanced smoothing. Where is it? Where is it? Okay, here. So this 8, you know why? You know why this 8 comes here? This is nothing but the document length of China class. Document length of China classes, we have 3 documents, which first document contains 3 terms, second document contains 3 terms, third document contains 2 terms. So just you add all these terms, irrespective of repeated or not repeated. 1, 2, 3, 4, 5, 6, 7, 8. So 8 comes here. Then this plus 6. Plus 6 is nothing but this B. This B is our number of terms in the vocabulary. This is unique number of terms, not repeated. Unique number of terms. So how many unique number of terms are there in the vocabulary? Chinese, Beijing, Shanghai, Macau, Tokyo, Japan, and which one is one more? 1, 2, 3, 4, 5, 6. Chinese, Beijing, Shanghai, Macau, Tokyo, and Japan. 6. So 6 unique terms, which is not repeated. 6 unique terms are there in the collection, in the vocabulary. So this is 6. 8 plus 6. And this 5 is nothing but this term TT. So this is your term frequency for China class. Term frequency for that particular term in China class. So you can see here, where is it? You can see here how many Chinese are there. 1, 2, 3, 4, 5. So how many Chinese? What is the term frequency for Chinese in China class? What is the term frequency for Chinese in China class? So 1, 2, 3, 4, 5. In document 1, we have 2 Chinese. In document 2, again we have 2 Chinese. In document 3, we have 1 Chinese. So total count is 5. This 1 is nothing but for Laplace smoothing, we add 1. For Laplace smoothing, we add 1. For Laplace smoothing, we add 1. So Tc plus 1. Tc is your term frequency for that particular term in the respective class, plus 1 is for at 1 Laplace smoothing, and B is the total number of unique terms in the vocabulary, and again T for the terms in the vocabulary. So this number is nothing but the document length, which I have just explained now for 8. Okay, so 5 plus 1 divided by 8 plus 6. You know how 5 comes, you know how 1 comes. 1 is from the formula at 1 smoothing. 8 is the total number of terms in the China class, irrespective of repeated or not repeated, which is equal to your document length. This is equal to your document length. And 6 is your what? 6 is what? 6 is what? Can
The
anybody?
number of unique terms.
Yes, the number of unique terms in the collection. So we have only 6 number of unique terms in this given example. So 5 plus 1 divided by 8 plus 6. This gives our conditional probability for Chinese in China class. Okay. We are going to find in 2 ways, one for China class and one for no China class. So first we have calculated for Chinese in China class, which is 5 plus 1 divided by 8 plus 6. So can anybody tell me how 5 comes for probability of Chinese in China class? How does this 5 comes?
The number of times China comes in the
Number of times Chinese occurs in China class, right? Number
yes,
of times Chinese occurs in China class. So in document D1 we have 2 Chinese, so 2 count, and in D2 another 2 Chinese, so 2 count, so 2 plus 2 4, and document 3 1 Chinese, so 1 count 5. So that's why 5 comes. 5 plus 1 is from the formula Laplace smoothing at 1. 8, you know it is document length. 6, number of unique terms. Similarly, we are calculating for Tokyo and Japan. Since Tokyo occurs only one time, it will be similar with Japan. So we have just together we have calculated. Say, let us see for Tokyo or Japan in China class. So what is the term frequency in China class for Tokyo and Japan?
0.
0, because it is not there in China class. So it is 0. Suppose if there is no Laplace smoothing, our probability will be 0, right? If there is no at-one smoothing, when we find probability for Tokyo in China class, it will be 0, because 0 divided by some numbers, it will be 0. That's why we have added plus 1 at 1 or Laplace smoothing in order to get a non-zero probability. So we are finding now, let us find the conditional probability for Tokyo in China class. So 0 plus 1 divided by 8 plus 6. This remains the same because 8 is the document length for China class and 6 is the number of unique terms in the vocabulary. So 8 plus 6, so 1 divided by 14. Now, probability of Chinese in not China class. Probability of Chinese in not China class. So, probability of Chinese we will find. So, here it will be 1 because in not China class, Chinese occurs only one time. Chinese occurs in only one time. So, 1 plus 1. This second one is for Laplace smoothing 1. 1 plus 1 divided by 3 plus 6. How does 3 comes here? Can anybody say how does 3 comes in the denominator?
It is the number of unique terms which is uh,
No, it's not
num
unique term. How does 3 comes here? 3 plus 6.
the number of terms in the North China class.
Yes, you can say number of terms in the North China class or document length. It is also known as document length. So for North China class, the document length is 3 because Tokyo 1, Japan 1, Chinese 1. So we have only 3 terms. That's why the document length is 3. So in the denominator, 3 it is written here plus 6. 6 is the number of unique terms in the collection, in the vocabulary. So 1 plus 1 divided by 3 plus 6, we got 2 divided by 9. Then Tokyo and Japan, another one. So in North China class. In North China class, Tokyo occurs 1 time, so 1 plus 1. For Japan also occurs 1 time, so these two probabilities will be same. So 1 plus 1 divided by 3 plus 6. Why I didn't find Beijing and Shanghai? Because it is not in the document test set. We are going to find only for the test set, T5. Chinese, Tokyo, Japan. That's why conditional probabilities are calculated for Chinese, Tokyo and Japan for both the classes. So Chinese, Tokyo, Japan for North China for China class and Chinese, Tokyo, Japan for North China class. So we have got all the probabilities, conditional probabilities for the terms in D5, which is not label 1. So 3 by 7 for Chinese in China class, Tokyo and Japan in China class 1 by 4, Chinese in North China class 2 by 9, Tokyo and Japan in North China class 2 by 9. Okay. So for D5, uh, just let me finish this slide. Only this slide number 10. I'll finish this because this is already explained. Now we get probability of D5 in China class. Let us see whether it is if there is any chances for D5 to belong in China class. It is calculated using this formula. This formula is nothing but where is it? Where is it? This one. Okay. For computing the probability of a document D being in class C is computed as. So this one, I'm using this formula for finding the probability. Okay. So this one, so 3 by 4. For this is D5 in China class. D5 in China class. So we are going to check this probability and we are going to check D5 in North China class. We are going to check these two probabilities and we will conclude to which class does D5 belong. Now 3 by 4, this is the prior probability. 3 by 4 we have calculated here. Prior probability for China class is 3 by 4. So that 3 by 4 I have written here. And after that, what is, see, in our test set, we have 3 Chinese and Tokyo, Japan. So for one Chinese, that means 5 terms are there. For Chinese, what is the conditional probability? 3 by 7. Another Chinese, so into 3 by 7. Another Chinese into 3 by 7. That's why I'm writing here 3 by 7 to the power cube. So 3 by 7 into 3 by 7 into 3 by 7 because we have 3 Chinese, right? In the test document, we have 3 Chinese. Now for Tokyo it is 1 by 4. For Japan also it is 1 by 4. So 1 by 4 into 1 by 4. So 1 by 14 into 1 by 14. Okay. Then you have to multiply all these conditional probabilities along with the prior probability. The first value is prior probability 3 by 4 multiplied by all the conditional probabilities for the respective terms. We have three Chinese, so 3 by 7 into 3 by 7 into 3 by 7. This is nothing but the conditional probability we got here. Okay. Now for Tokyo it is 1 by 14, for Japan it is 1 by 14, it is written here 1 by 14 into 1 by 14. So after multiplying all these values, we got approximately 0.0003. Similarly, you have to calculate for North China class also. For North China class, the first one is prior probability value. So prior probability for North China class is 1 by 4. We have calculated here. So that 1 by 4 it is written here, and after that we have 3 Chinese, right? So 3 Chinese. So in test set we have 1, 2, 3. So for conditional probability of Chinese in North China class, conditional probability of Chinese in North China class. So in North China class it is 2 by 9. It is 2 by 9. So there will be 2 by 9 into 2 by 9 into 2 by 9. Since we have three Chinese here, for its respective probability, conditional probabilities will be multiplied. So 2 by 9 into 2 by 9 into 2 by 9. For Tokyo, what is the value? It is also 2 by 9. So 2 by 9 into 2 by 9. So there will be multiplication of 5 2 by 9s. Okay. So so here 2 by 9, 1 by 4 is the prior probability for North China class. Then for North China class, conditional probability for Chinese, conditional probability for Tokyo in North China class, conditional probability of Japan in North China class. Multiply all this, we get 0.0001. So you check these two probabilities. Which one has the higher probability? So, which one is the higher probability? Which one has the higher probability? Probability of D5 in China class or probability of D5 in North China class? Which one is
In China class.
in China class? Right. So, the probability of D5 in China class has higher probability value. Therefore, it also has the higher chances of uh, belonging to the China class. So that's why the classifier will assign the test document D5 to China class. The classifier will assign the test document D5 to China class. So this method is known as text classification using NAIP Bayes. NAIP Bayes text classification. Okay. So why others are not responding? There are 47, 49 students in the group. Only one student is responding. What happened? Did you understand this classification today? Classification part is clear or not? Is it understood to all of you? NAIP based classification, text classification is clear. Anyone has doubt in this? Deepak Kumar, did you know NAIP based text classification? If I give you example, can you solve it?
Yes, ma'am.
Did you understand NAIP based classification, which I have explained now?
Yes, ma'am.
Okay, then how to find the conditional probability for Tokyo?
Conditional probability of
Tokyo, conditional probability for Tokyo. You can even see the slide and explain if you understand.
Tokyo.
Conditional probability for Tokyo. You can see from the slide and you can explain if you understand. Because this part is very important, that's why I've asked you. For your exam portion, this part is very important. Helium by long jump. So Deepak Kumar doesn't understand how to calculate the